Okay, this is going through some problems on 3.8, which involved, the title being Other Equations. So it still involves using quadratics eventually, but right away you're not necessarily working with quadratic equations. So let's start by, I guess let's do something like f here. So here not only do I have one term with them, or expression with a variable expression under square root, I have two. And so in order to deal with it, I've got to get rid of one square root at a time. So I'm going to first deal with getting rid of 2x minus 3, that square root. And so this is going to equal, sorry, I got to expand this a little bit so I can see, equals, I'm going to bring the square root of x plus 7 to the other side and the plus 2 to the other side. Okay, so now at this point I've isolated one of the square roots. I'm going to square both sides. And so that's going to get rid of the square root around the 2x minus 3. However, I'm still going to have square roots on the right side. So I'm going to get x plus 7, but the middle term when I FOIL, I'm going to end up with minus 4 times the square root of x plus 7, then plus 4. And now we're kind of back to some earlier problems, A through D, where I have a single expression under a square root. And so I'm going to isolate that. So I'm going to bring the 4 and the x plus 7 to the left, and I'm going to bring everything else to the right. So it looks like I have negative x, let's see what I get here, plus 14. 11 plus 3. Yeah. Okay, so now at this point, now we're, again, squaring both sides. So in this case, I'm going to get 16, and it's going to be times x plus 7 equals x squared minus 28x, and then I'm going to have to do 14 squared, which I don't know off the top of my head. So that's going to be 196. And yeah, that's right. Okay. And so now I've got 16x plus, let's see, I think that's 112, 16 times 7. Yeah, equals x squared minus 28x plus 196. And I've got a quadratic. How do I deal with the quadratic? We'll get everything in one side, and then I can assess the strategy for solving the quadratic. So I'm going to get minus, let's see, minus 44x. And then I'm going to get plus 4. Plus, I believe, 84. Yeah. Okay, so I actually, believe it or not, can factor this to x minus 42, x minus 2. And so you get x equals 42 and x equals 2. So remember, though, you've got to check. Because I squared both sides, not once, but twice, I'm going to have to check to see if these work in the original. All right, so if I plug in 42 to the original, I get 84 minus 3, or square root of 81. So I was going to get 9 minus 42 plus 7 is 49, which is 7, plus 2. Does that equal 0? That would be a no. Okay, so now let's try the 2. If I plug in 2, I get square root of 4 minus 3, or square root of 1, which is 1, minus square root of 9, which is 3, plus 2, which indeed equals 0. Okay, so x equals 2 is my only solution there. So when I turn to something like G and H, the nice thing here is the third root of something. In order to undo that, I'm going to raise both sides to the third power. And in that case, because a cube root of a negative is negative and a cube root of a positive, that I don't have to worry about the sign issue of essentially making everything positive like I do with the when you have even roots, so I don't have to worry about the extraneous root situation. So let's do something like H. So the nice thing here is I don't have any sort of constant term. So if I isolate one of the expressions under a cube root, notice then I can raise both sides to the third, and that will undo both. So 3x squared minus 9x plus 8 equals x. Bring everything to one side. Minus 10x plus 8. And let's see if we can get this to factor. The only possibilities for 3x squared are 3x and x. And then I would need I'd need both to be the same sign. So in this case, I need them to both be negative. So looks like 4 and 2, because then I'll get minus 4x and minus 6x, which is minus 10. Okay, so x is 4/3 or x equals 2. I did not, again, I cubed both sides, raised both sides to the third. I did not square both sides or raise both sides to an even power, so I'm not gonna check there. You could just to double, if you wanted just to, double check that you didn't make it a careless error, totally acceptable to do that. Okay, so now we turn to the other type of equations and the most obvious is when you have a trinomial and two of them have variable components and one doesn't. So the question is, can I do a z substitution to make it quadratic? And some are going to be obvious and some are a little bit more interesting. So I guess let's do an obvious and then we'll do a more interesting. An obvious one is something like b. So if I let z be y to the 1/6, then z squared is equal to y to the 1/3. So that works out nicely. So I get 2z squared minus 3z plus 1 equals 0. And then I can solve. Just make sure at the end you plug back in what z is, and so you can actually solve for y. Something that might be less obvious is something like d. So here's what you have for d. You have 5a to the 1/4 plus 2, and I'm going to write it like this, a to the 1/4. So that negative, I'm going to bring that variable to the bottom to make it a positive exponent, equals 11. So I find it's easier to actually, even though it's not going to initially make it a quadratic, it is just easier to work with. So if I let z equal a to the 1/4, I can rewrite this as 5z plus 2 over z equals 1. And now to solve this, I'm going to multiply both sides by z just to get that out of the denominator. And here's where I get a quadratic. 5z squared plus 2 equals z. And then I can bring to one side everything. Minus z plus 2 equals 0. And, it's not, why am I saying minus? It's 11. Yikes. All right, let me erase that. Hold on. I don't know why I had 1. 11z. I can just add that in. Minus 11z plus 2. And in this case, actually, it's easily factorable. 5z and z minus 2 minus 1. Then I'm going to get minus 11z. So z is equal to 1/5 or z is equal to 2. And just don't forget to go back and solve for actually the variable in the initial problem. So a to the 1/4 equals 2. So a equals 16 or a equals 1/5 to the 4th power, which I could do out, but I won't right now. I think it's 1, I think it's 1 over 625. Because 125, yeah, 1 over 625. So that's not the traditional, like you like some of the earlier problems where you immediately get a quadratic, but a substitution just helps work through the problem, so then you are working with a quadratic. So again, it's good to go through these problems to see the different types of algebraic manipulations you can do in order to make the problem solvable.